So you feel pretty good about the basics of Python, right? Well, it's time to level up. In this explainer, we're going to unlock the professional's toolkit. We're talking generators, decorators, and context managers. These are the features that make Python code not just work, but become truly powerful, efficient, and honestly, pretty elegant.
Let's start with a question. I mean, you write for loops all the time, maybe every single day. But have you ever stopped to think about what Python is actually doing when you write that simple line? What's going on under the hood? Because the real process is way more interesting and, frankly, more clever than you might think.
And that question brings us right to our first deep dive, the secret engine of loops. We're going to go from the simple loops you already write to unlocking some incredible memory-saving superpowers.
So when you type this incredibly common line of code, it feels so simple. But Python isn't just, mindlessly repeating an action. It's actually following a very specific, strict set of rules, a protocol. This simple syntax is just a beautiful, clean shortcut for a much more involved process happening behind the curtain.
And here's that hidden process broken down. It's like a three-step dance. First, Python calls a function called iter on your list. That gives it back something called an iterator object. Then, for every single turn of the loop, it calls next on that object to get the next item. It just keeps doing that over and over until the iterator sends up a flare, a special signal called stop iteration, which tells the loop, hey, we're all done here. This simple protocol is the engine for every single for loop you've ever written.
Now, if an iterator is the engine, then a generator is like a supercharged, hyper-efficient version of that engine. See, instead of holding every single value in memory at once, a generator creates them one at a time, on the fly, using a magic keyword, yield.
And this slide, wow, this perfectly shows why that's such a game changer. On the left, with the square brackets, you're creating a massive list with a million numbers in it, all at once. That's eager evaluation, and it can eat up your memory. But look at the right. Just by switching to parentheses, you create a generator. It hasn't calculated a single thing yet. It just sits there, ready to give you the next value whenever you ask. That's lazy evaluation, and the memory savings can be absolutely enormous.
All right, let's switch gears to another powerful concept. Our next section is all about functions that wrap other functions. We're going to talk about decorators and how you can use them to add superpowers to your code without changing a single line of the original function.
Honestly, the best way to think about a decorator is to picture it like gift wrapping a function. The original function is the gift inside the box. The decorator is the wrapping paper, the ribbon, the bow. It adds extra layers of behavior. Maybe it logs when the function starts and stops, or times how long it takes to run. It's extra stuff that happens before and after your original function does its job.
So before we get to the really cool shortcut, let's see how you would actually do this manually. First, you've got your original function, right? Greet. Then you define a new function, a wrapper, that does something extra, then calls your original greet function and maybe does something else after. Finally, and this is the key part, you reassign the original name greet to now point to your new wrapped version. It totally works, but it's a bit clunky, isn't it?
Of course, there's a much cleaner, more Pythonic way to do all of that. This is Python, after all. And it all comes down to a single, elegant symbol. The @ sign.
And here it is. Just look at that. By just placing @logger right above our add function, we're telling Python, hey, wrap this function for me. That whole messy manual process of creating a wrapper and reassigning the name, it's all handled automatically by this one beautiful line of code.
Okay, on to our next essential tool. This one is all about automating your code's cleanup. It's about making sure you never leave a mess behind. We're talking about the magic of context managers and how they provide guaranteed safety for your resources.
I'm willing to bet you've written code that looks almost exactly like this, probably 100 times. That with statement for opening files is one of the most common patterns in all of Python. And guess what? You've been using a context manager this whole time, maybe without even knowing what it was called. The with statement is like a contract. It guarantees a very strict life cycle. As soon as you enter the block, a special method called __enter runs to set everything up, like opening the file. Then your code inside the block runs. And here's the magic part. After your code is done, an __exit method is guaranteed to run, no matter what. Even if your code crashes with an error, that exit method will run and clean things up. It's safety by design.
Okay, so we've looked at iterators, decorators, and context managers. That's a lot of theory. Now for the really fun part. Let's build something. Let's see how we can combine all of these advanced tools with one more key idea:
serialization. So what even is serialization? It sounds kind of complicated, but the idea is actually super simple. It's just the process of taking a Python object, a dictionary, a list, even a custom class you built, and turning it into a format that you can save in a file. It's how you make your programs remember things after you close them.
And in Python's standard library, you basically get two main flavors. You've got JSON, which is awesome because it's just human-readable text, and it works with almost any other programming language out there. Then you have Pickle. It's Python-specific, but its superpower is that it can handle pretty much any complex Python object you can imagine, things that JSON just can't touch.
Okay, let's put it all together. We're going to use all these concepts we've discussed to build a simple but totally complete student management system. This is where the theory hits the road.
Now, instead of just throwing a giant wall of code at you, let's look at the blueprint. This shows how every single piece we've just talked about has a critical role to play. We'll use classes to represent our students. We'll use JSON serialization to save and load our data. We'll use context managers to handle our files safely. And of course, the whole thing is tied together with proper error handling and the loops and conditionals you already know. Every concept has a job.
And with that, you've really connected all the dots. This quote just nails it. You now have a complete foundation of Python, from beginner to advanced, capable of building real applications. You've truly moved beyond just writing simple scripts to being able to architect robust, professional programs.
So, let's end with this thought. You've just unlocked the professional's toolkit. You now know how to write code that isn't just functional, but also efficient, safe, and truly elegant. The only question left is, what powerful, efficient, and elegant code are you going to go build next?